Welcome to another AQA AS Chemistry video. I'm doing another video now. So this is a continuation from the previous video. This video is just gonna be me answering the rest of this paper, going through mark scheme at the end, and yeah. So this is just calorimetry questions, how they come up. This isn't just the only question, but this is like the main kind of questions that could come up. If you want to do this paper, I left the link in the description of the previous video, so go check out that. But I might leave it in this video just in case. But yeah. Alright, so this is a continuation. So this is done in 36 minutes. So I'm going to try and set a timer for 36 minutes to try and do that. I'm going to be explaining it as well at the same time. So if I don't explain it at the same time and complete it in the same time, just, you know, I can do it. I have done this before. I haven't done this paper before, but, or maybe I recognize some of the questions, but, I've already completed my A levels, but you need to be able to do this in a mark per minute. I know in a real exam they give you a bit more than mark per minute, but I'm trying to aim to do this in the mark per minute. So I'm going to set a timer now of 36 minutes. Let's go. So the figure below shows apparatus used in the experiment to determine the enthalpy of combustion of a leaf alcohol. The alcohol is placed in a sperm burner and weighed. The burner is lit and the alcohol is allowed to burn for a few minutes. The flame is extinguished and the burner is reweighed. The temperature of the water is recorded before and after heating. Okay, so write an equation for the complete combustion. Alright, so sometimes you can just skip this if you know it's just complete combustion. So what is this now? So this, by the way, this is actually how you do it in the real experiment, right? For measuring determining the enthalpy of combustion. You get a spirit burner with a weighed amount of your compound, of your alcohol in this case, and then you measure the difference in weight from before and after your reaction, and then once that has occurred, you would the difference in mass is the amount that's been used for this combustion reaction, and then you measure the temperature change, and then so on forth. But anyway, this question is about. This is just a simple completing the equation. I'm going to need more space. If you haven't got space on the thing, you can just go and do this and then highlight it later on. So here's an open form water. We've got 1, 2, 3, 6 carbons. 3, 4, 5, 6. 3. That's 12 carbons. So 12 hydrogen. So I can just 6 H2N. That's 12. 18 oxygen on this side. 3 on this side. That's 9. That's 18. So if I make it 8.5, which is 17 over 2. That's 17, and then plus the 1, 18. Alright, and then try and make that clear. Underline that. And that's what it's meant to be there. Try and make it more clear than I did because mine was just kind of messy, but you kind of get the point. Use the results from the table above to calculate a value for the enthalpy of combustion of the leaf alcohol. Give units in the answer. So give units in your answer. Okay, so first for Q is equal to MC delta T. We have the mass of the water is 50 grams, as I said there. And then the temperature change is 40.8 minus 20.7. So temperature change equals to 40.8 minus 20.7, 20.1. So Q is equal to 50 times by 4.18 multiplied by 20.1. joules. Delta H is equal to, so our energy, or the enthalpy, is just 4,200.9 joules. Delta H is equal to Q over the moles. Moles is equal to the mass over the mR. The mR of alcohol is equal to the 6 carbons, so 6 times by 12, 72, plus 12 hydrogens, plus 12, and then there's 1 oxygen, that's 16, so 72 plus 12 hydrogens plus 1 oxygen, so that's 16, and then the mR of this, I'll add that all together, obviously. 72 plus 12 plus 16, 100 moles equal to the mass, which is, what's our mass again? The difference, you have to work out the difference in mass, so 56.38 mass is equal to 56.38 minus 55 point what? 84. And that's equal to, so then mass of alcohol, 56.38 minus 55.84, 0.54 moles is equal to 0.54 over 100, which is just 5.4 times 10 to the power of minus 3. And therefore delta H is equal to 4,200.9 over 5.40 times 10 to the power of minus 3, and that's equal to 777,944, and that's joules per mole. But I prefer leaving it as, I forgot to mention that this is minus 4,000. This is minus 4,200.9 joules. But I actually know what I'll leave it as 777,944, and that's equal to 778 kilojoules per mole. But remember, this is an exothermic reaction, so it's actually minus 778 kilojoules per mole. So minus 778 kilojoules per mole. Alright, state how your answer to part B is likely to differ from the value quoted in reference source. So one, B will be lower because then what part? Then it will be less negative. I guess if it's less negative, it's more positive. It'll be less. I'd say it'll be less exothermic, or less. Say slash. I think it's less exothermic, or you could say less negative, I guess. I say more positive. As energy is lost has heat. A 50-gram sample of water was used in the experiment. Explain how you could measure out this mass of water without using a balance. Measure the volume of water. Density is equal to mass. Volume, mass. Water has a density. Water has a density of 1. So multiply the density by the volume to get the mass. I mean, you don't really need to, but I mean, technically just mentioning that it's mentioning this, I guess, is probably important. If it's just times by 1, it's not really making that much of a difference, but I don't know, that's what I see. Ethanol is an important fuel. I mean, this is a longer mark question. You kind of see if any... Yeah, this is a calculation question. I'll go to the next question. It's a calculation question. I'm just not bothered to do that right now. A student carried out a laboratory experiment to determine the enthalpy change when... I'll do that at the end. Determine when a sample of ethanol was burned. The heat produced was used to warm some water in a copper calorimeter. The student found that the temperature of 75 grams of water increased by 5.5 degrees when 2.4 times 10 minus 3 moles of pure ethanol was burned in air. So use the stated results to calculate the enthalpy change and use 2 reasons why the student's value. Okay, that's fine. So, how to do this? I would do Q is equal to MC delta T. So first of all, they want us to work out the enthalpy change, and then they want us to describe why the enthalpy change is different compared to the data book, right? And I'll go for that part after. But first of all, the calculation: 75 times by 4.18 times by, they tells us that it increased by 5.5, so that's 5.5. Q is equal to, so 75 times by 4.18 times by 5.5. 1,724.25 joules. Delta H, they've already given us the moles, so it's equal to Q over moles. Delta H is equal to 17. I mean, you can round this to 1724.3. 24.3 over 2.4 times 10 to the power of minus 3. Delta H is equal to, answer, over 2.4 times 10 to the power of minus 3. 718,437.5 joules per mole. Delta H is equal to, oh, it's actually minus 7. Is that because it's an exothermic reaction, remember? So it has to be minus 718,437 or minus 718 kilojoules per mole. Alright, cool. We've done that part now. Now you have to do 2 more reasons. I always do these little boxes next to my thing. So I've done the first part of the question. It's used 2 reasons why. Well, first of all, one reason is energy is lost during the reaction as heat. Incomplete combustion causes, incomplete combustion means not all of the reactants have reacted. Mean bond enthalpies can be used to calculate the enthalpies of a reaction. Give the meaning of the term mean bond enthalpy. It's the average bond enthalpy over a range of molecules. And is the bond enthalpy and it's the energy required to break the bond. Oh, shit questions, man. Sorry, man. Alright. Consider the mean bond enthalpy in data in the following table. Alright, well, we already know what this type of question is. Sometimes you don't really need to read. Always read the question, but sometimes you just really don't need to. Use data in the table above and the equation shown in the to calculate a value for the bond enthalpy of the bond here. It means it's very obvious what it needs to do, but anyway, write out the equation. Delta H is equal to delta H of reactants minus products. So I say products. Okay, bond enthalpy is your enthalpy change of your reactants minus your products. So minus 1279. I'm writing it down here because there's just not enough space to do it. I've learnt my lesson with doing these questions. 3, 4, 5. 5 by 412 plus 348 plus 360 plus 463 plus 6, no, is it, how did I say 6? Plus 3, yeah, plus 3 by, or 3x actually, by 3x minus the product side, which is 4 by 805 plus, what time have you got now? 18 minutes left to answer the rest of the questions by, and then plus H2, that's 6 by 463. Alright, so it's just have I done this right? Yeah, that's fine. No problem. 348 carbon, oxygen plus 360, yes. Yeah, that's fine. I don't know, for some reason I thought there was just best, I was just bugging, to be honest, I'm just bugging. 1279 equal to 3231 plus 3x minus 4 by 805 plus 6 by 463. 5998. I don't know why I thought I was bugging there. So I guess 3x is equal to that goes over to, so 598 minus 1279 minus 3231, 3231, 1488. X is equal to that over 3. Answer over 3. There you go, 496 kilojoules per mole. It took longer than I expected for that question for some reason. I don't know why. Anyway, 16 minutes left to answer 12 marks. I'm including the other one we missed out before. So, a 5 gram sample of potassium chloride was added to 50 grams of water initially at 20 degrees Celsius. The mixture was stirred and potassium chloride dissolved. The temperature of the solution decreased. Describe the steps that you take to determine accurate minimum temperature that's not influenced by heat surroundings. So this is just saying a practical out. If you know this, then okay, then it shouldn't be a problem for you. But I'll just say so. Add 5 grams of potassium chloride to calorimeter or 50 grams of water. Let's see it off. And start the stop clock. Start the stop clock. How many marks is this? 4 marks. Measure temperature change every minute for, I don't know, 5 minutes, for 5 minutes. Just showing that you have, you're doing it in regular intervals, right? And then once you measure temperature change every minute for 5 minutes, record data and plot a graph of temperature against time. And then extrapolate the graph back to t equals 0. Temperature of the water decreased to 14.6 degrees Celsius. Calculate value in kilojoules per mole for the enthalpy of solution of potassium chloride. You should assume that only 50 grams of water changes in temperature and that the specific heat capacity of the water is 4.18 joules per Kelvin per gram. Give your answer to the appropriate number of significant figures. Alright, so actually, enthalpy solution. This is a year 2 thing, but if you're watching this from year 2. Alright, so now go straight into this question. Don't worry about the scribbling out, I was just being very silly. Enthalpy of solution. Calculate the value in kilojoules per mole for the enthalpy of solution. Q is equal to MC delta T. Q is equal to 50 times by 4.18 multiplied by the change in temperature, which is 20 minus 14.6. Q is equal to by doing this, you're still representing your change in temperature, 20 minus 14.6. 1128.6 moles is equal to the mass over the MR. Mass of the moles of potassium chloride, 5 over, I think 39. What's 39? I think it's 39.1. But in case I'm wrong, yeah, 39.1 plus 35.5. What the hell that is? 5 over 39.1 plus 35.5. 6.70 times 10 to the power of minus 2. delta H is equal to Q over the moles. Delta H is equal to 1128.6 over 6.70 times 10 to the power minus 2. Delta H is equal to 1128.6 over 6.7. 16,844.8, which is roughly 16.8 or 16.8, approximately 16.8 kilojoules per mole if we're rounding it down. So 16.8 enthalpy of solution. That might be negative, but I'm pretty certain it's negative. It decreased. If the temperature decreased, then surely that would be negative. Final temperature is 14.6 minus, so it should be, it actually should be 14.6 minus 20, which is minus 5.4. Guys, don't make mistakes as me. Don't be messy like me. So it's actually negative this. Alright, the enthalpy of solution of calcium chloride is minus 82.9 kilojoules per mole. The enthalpy of hydration of calcium ions and chloride ions are minus 1,650 and minus 464 respectively. Use these values to calculate a value for the lattice enthalpy of dissociation of calcium chloride. Also, by this question, they usually give you a bit more space in case you make a foolish mistake like that. Alright, so this question here is a year 2 question, so I'm not expecting you to answer it, but if you are a year 2 student and you're trying to do this question, I'll kind of go for it. So delta H is equal to the enthalpy of solution is equal to enthalpy of a lattice dissociation. I'm not expecting people who haven't done year 2 to understand this, but if you are year 2 watching this, then yeah, then you should be fine. If you're year 2, then this is no problem for you. But anyway, that's the equation for enthalpy of solution. Is enthalpy of lattice dissociation plus the sum of all the enthalpy of hydrations. Enthalpy of, if you're just trying to work out the enthalpy of lattice dissociation, rearrange the equation so that you have enthalpy of solution minus the sum of the enthalpies of hydration, enthalpy of lattice dissociation minus solutions at minus 82.9, sorry, minus well, it's calcium chloride, so it's AClCl2, so it's actually 2 times by that, so it's minus 1,650 plus 2 by minus 364. And if you realize now it's minus minus, the whole thing is minus minus, so it's minus 82.9 plus 1,650 plus 2 by 364. It's actually plus 2,378, maths here, and then minus 82.9. The enthalpy of lattice dissociation is equal to 2,295.1. That is just a positive value because it is lattice dissociation. It's an endothermic reaction. So 2295.1. Explain why your answer is again, this is the year 2 content, so I mean actually it's part of year 2, part year 1, right? Explain why if they're asking you why the answer part is different from the lattice enthalpy of dissociation magnesium chloride, and it's actually to do with charge densities or the nuclear charges, but because Mg2, so Mg2 plus is a smaller, it's actually related to some of the content I've been doing so far. It's a smaller ion than Ca2 plus. If you look in the periodic table, Mg2 plus is actually smaller than Ca2 plus. So it has a higher charge density. And hence has a stronger electrostatic attraction. Has a strong electrostatic attraction to the Cl minus. So more energy is needed, so more. Do I have to say more energy is needed? I've already said the main point there, really. Alright, fine. Ethanol is an important fuel. A dilute aqueous solution of ethanol can be produced by the fermentation of aqueous solution of glucose. Is claimed that the ethanol obtained from this solution is a carbon-neutral biofuel. Write an equation for this fermentation reaction. Give two other essential conditions for this reaction to produce a good yield of ethanol. Name a process that used to produce a more concentrated solution of ethanol from this. Okay. And state the meaning of the term carbon neutral when it comes to biofuels. So this is just, from what I understand, this is just a anaerobic respiration of glucose, C6H12O6, right? And that goes to form ethanol, CH3CH2OH plus CO2. If I have two of that, four, and then two, so that, hydrogens, that's 6, that's 12, that's fine, and oxygens, 2, that's 4, that's, okay, that's 6, okay, that's fine. Give the two other essential conditions for this reaction to produce a good yield of ethanol, and say high temperature, no, and I'd say it needs anaerobic conditions, and done inside a yeast cell, And then process used to produce a more concentrated solution of ethanol from a dilute aqueous solution. So if I want to dilute aqueous solution, then I would just do I'd do simple distillation. So I say it could be fractional. I would just say distillation, just to make sure I don't get anything. Distillation. Just to make sure that I don't get anything wrong. And then state the meaning of the term carbon neutral and condensed biofuel. Carbon time, by the way, got 5 minutes left, so I actually did really good for timing. Carbon neutral means the net. There's a zero. I said there's a net CO2 emission of 0. There's a net CO2 emission of carbon dioxide. I said there's no net. There's net CO2 emission of 0. To the atmosphere, yes. To the atmosphere. Alright, that's it. 4 minutes 10, 4 minutes 9 or 4 minutes 10 left to spare. Go over it. It's just making sure that it's actually clean, like things like this here, alright? Would I rewrite this again? let me see if I can write it here. 50 times by 4.18 times by minus 5.4. Q is equal to minus 1128.6. So I just do that there. So it's 14.6 minus 20. Final minus the initial. That's it, really. Okay, now I'm going to go through the mark scheme of this. So I'm going to go back to, these questions are from the previous questions, so I'm going to go through the mark scheme now. Should I go like this, or? Alright, so first question, that's correct. You can say to speed up, second one, to speed up the reaction provides a catalyst or catalyzes the reaction, or acts as a catalyst, for providing an enzyme. The third one, that is balanced. Secondary alcohol. You get a mark for saying Q equals MC delta T, or for just writing it out. The equation 150 times by 4.18 times by 8. 5,016 joules. If you got to this part here where it's minus 115, then you've pretty much just got your answer correct, really. But I'll show you what. That's how they broke the mark. That's how they broke it down, in case there's any confusion. So that, and then the third one is getting the correct answer, yeah. Yeah. D. Enthalpy of combustion. The enthalpy change when 1 mole of a substance, I've said when 1 mole of a substance is burned completely in an excess of oxygen. Yeah, burned completely or in an excess of oxygen. And all reactions are in the standard states. Yeah, so that's just going to be, that's 3 marks right there. Yeah, 3 marks. This one here, I might really bother to go through every single part, but if you got to minus 1651, you've done the correct parts. But make sure that that if you do is reactants minus the products, right? You get a mark just for saying that part, and you actually miss out a mark if you don't mention that. But that's the part. Then if you got that part right, then you pretty much just got the rest right, because you're just breaking it down. All right, so the next part, F. I was worried about this one, which is heat loss. Okay, so heat can be lost to surroundings, and then it could be incomplete combustion. Actually, it was the second one, actually, so yeah, that's fine. Increased in volume. Yes, it's increased in volume from this one. And there's an increase in, so there's a smaller increase in temperature, increased contact between calorimeter and the water. So there's an increase. I said that there's an increase in the contact between the water and the calorimeter, so there's that. Balancing out this, they've used 8.5 or 17/2 and 8.5, same thing really. They usually actually accept if you leave as a fraction, but same thing, top heavy fraction or mixed fraction, same thing. I've seen it given. This is not the new mark scheme, by the way, so yeah. Next one, minus 778. Anyways, I could just break it down and show you each part, but I've already broken it down for you, so I'm just going to go through the answers. Minus 778 kilojoules per mole. Alright, so it'd be less negative, or I should have said less negative. It said it here, but I went to say less exothermic or more positive. More positive? I shouldn't, I say less negative. I'll lose a mark there for not saying less negative, but I think more positive would have been fine, but alright, less negative. Less negative than reference. If anyone starts saying why you're not using a green pen, I don't care. less negative than reference. Water has a known density of, what was the same question? It's a heat loss, yeah, heat is lost to the surroundings, so heat loss, so I get 1 mark out for that one there. Water has a known density of 1, that's in brackets, but it says water has a known density. Measure the volume of water. Water has a density of 1, therefore volume of 50 centimeters cubed could be measured out. Well, I went a bit too deep into it. I said measure the volume of water. Water has a density of 1, so multiply the density by the volume to get the mass. So I should have maybe used it. I should have said more like that, to be honest. I mean, it is pretty self-explanatory. I've put a bit too deep in it, but just saying that water has a known density, therefore volume of 50 centimeters cubed could be measured out as the mass. But this part here, check with your teacher if they allow that. They probably wouldn't allow that, but sometimes it's just as simple as just saying that water, you know, water's density, so therefore it's 1, therefore a volume of 50 centimeters cubed is the same as 50 grams. All right, so yeah, I wouldn't have got any marks for that. The next part, the equation, that is correct. Conditions, enzyme, yeast, I have to say yeast cell, 25 degrees Celsius, so a high temperature, anaerobic conditions, so that's another mark. So done inside a yeast cell, anaerobic conditions, that's 2 marks there. Distillation, so I would have got a if I said simple distillation, I would have lost a mark, but I could have been correct with fractional distillation, but distillation nonetheless, if it's in brackets, it means that it doesn't need to be, it's not necessary to gain you the mark. And it's saying carbon neutral means there's a net CO2 emission. Sorry, carbon neutral in this context means there's no net / overall carbon dioxide CO2 emission in the atmosphere. It's more or less what I said, so yeah, that's fine. I mean, it's more examples of it, so that's not a problem. The next one, did you get minus 718 kilojoules per mole? Then you would have got this correct. I already broken down the answer, so yeah. I said that energy is lost due to heat loss and incomplete combustion. So heat loss and incomplete combustion. The next one, this one's actually quite concerned about because I was worried about getting this one wrong. But C, enthalpy, or the heat energy change at constant pressure, the energy needed to break or dissociate covalent bond. I said that part, and it's the average for that type of bond over a different range of molecules. I said that part. I said part 2 first and part 1 first, but either way, you know it's the same thing, right? So that's getting the mark there. This one here, you don't actually have to say OO, but I represented it as X, but I really want you to show that you understood how to break this down. Reactants minus products, again, that's a mark just for saying that. And then if you've got 496, the answer is correct. For the next one, add 5. Oh, just saying start a clock when KCl is added to water. So I didn't have to say this part, but start the stop clock. So start the stop clock, that's a mark. Record temperature every subsequent minute for 5 minutes, or measure temperature change every minute. I shouldn't say measure temperature change. It should just be measure the temperature every minute for 5 minutes. I'll be wrong actually. Record data and plot a graph of temperature against time. Plot a graph of temperature against time. And extrapolate graph back to t equals 0. 3 marks. The next one, oh, it's plus 16.8. That is my bad. It's plus 16.8. So I would have lost the mark there for saying the wrong sign. I would have been right in the first place, just leaving it as it was, but no, it's 20 minus 14.6. So if I said the water decreased, though, shouldn't it be final temperature minus the initial temperature? Anyway, my bad. That's what it should have been, and it's just normal plus 16.8, not minus 16.8. So that's what I'm. So yeah, I can make mistakes as well. I haven't done this for a long time, so please don't get on to me. But yeah, what I initially wrote down was correct. what I initially wrote down, but obviously I went on to say that the temperature here, but yeah, it's all temperature decreased, but I don't know. It's really late now. I should just go and continue before my parents start getting mad anyway, man. If you've got 2295 and the next one after that, kilojoules per mole. That's it. And Mg2 plus is a smaller ion than calcium ion, therefore it attracts the chloride ion more strongly, or stronger ionic bonds. Hopefully this video was helpful, and that's it.